Welcome students, I am Sudipto Karmakar, Assistant Professor of Physics, Department of Basic Science and Humanities, Swami Vivekananda's Institute of Science and Technology. Today we are going to solve a question that came in MAKAUT odd semester examination in the year 2019-2020. The question is from the topic quantum mechanics, and the question is: calculate expectation value of p squared of wave function psi of x equals to root under 2 by L sin pi x by L from x equals to 0 to x equals to L. This question is of 5 marks and we are going to solve this question. So let's start. We all know the definition of expectation value of any dynamical variable. That is, if A is any dynamical variable, then its quantum mechanical expectation value for any state psi of x is given by this standard definition. That is, average of A, that is the expectation value of A, equals to integral from minus infinity to plus infinity psi star of x a cap psi of x dx, where A is the dynamical variable which is often called the observables in quantum mechanics, and a cap is the quantum mechanical operator corresponding to the dynamical variable A, and psi of x is the wave function that is given in the question, which is equals to root under 2 by L sin pi x by L. Psi of x equals to root over 2 by L sin pi x by L. Now, in the given question, here the dynamical variable, it is p square, which is the square of the linear momentum. So I can write p square as p cap square, where p cap is the linear momentum operator. So in this question, a cap, which is the quantum mechanical operator, in this case is p square, and we are going to find out the expectation value of p square. Now we all know the expression for, or the quantum mechanical expression for p square or p. We know that p cap, it is the quantum mechanical linear momentum operator, and its expression is p cap equals to minus I h cut del del x, that is partial derivative with respect to x. Here h cut is reduced as constant and I is all known, that is root under minus 1. Therefore p square can be written as p cap square. Now p cap square is nothing but the product of the two linear momentum operators, that is p cap into p cap. Now p cap is minus I h cut del del x. It is multiplied by again p cap, that is minus I h cut del del x. If we multiply these two p caps, that is these two linear momentum operators, then we have minus minus cancels out, I into I, that gives us minus 1. I have written that minus 1 as this minus sign here. H cut into h cut, that gives us h cut square, and if we take two partial derivative consequently, then we have del 2 del x2, that is second order partial derivative with respect to x. So we have our expression for p cap square, that is minus h cut square del 2 by del x2. So we have already evaluated the expression for p square. Now we are going to calculate its expectation value for the given wave function. Therefore, the expectation value of the given operator, that is for the given dynamical variable p squared, between the range from x equals to 0 to x equals to L. So we have to fix this initial and final limit. So the expectation value or the average value of p square, that is equals to integral, here the lower limit I have set x equals to 0, and in the final limit I have already written L, because we are going to find the expectation value for this specific range from x equals to 0 to x equals to L. So I am writing the initial limit as 0 and the final limit as L. Chi star x p cap square chi of x dx. Now what is chi star x? Chi star x is the complex conjugate of the given wave function. It is the general definition of any average value of dynamical variable. So I have written chi star x of chi star x p cap square chi x dx. Now I am writing the expression for given wave function, that is root under 2 by L sin pi x by L, and taking its complex conjugate here, denoted by star. Now we have already evaluated the expression for p square, that is minus h star square del 2 del x2, that will be operated on chi of x, that is root under 2 by L sin pi x by L dx. Now since there is no imaginary term within this second bracket, in the first term there is no imaginary quantity or any complex quantity in this first second bracket. So after taking complex conjugate, root under 2 by L sin pi x by L will remain unaffected. So I am writing root under 2 by L sin pi x by L. Now what about this operated term? I am again writing minus h star square del 2 del x2, that is going to operate on this wave function root under 2 by L sin pi x by L dx. So from now it is normal mathematics, there is no tremendous physics from here right now. Now taking minus h star square and 2 by L outside of the integral sign, we have the first term as sin pi x by L, and del 2 del x2, that is the second order partial derivative, is going to operate on the wave function, that is the sine term of the wave function, that is sin pi x by L. So we all know that if we take second order partial derivative on sin x, it will we will have minus sin x, right? So after taking second order partial derivative with respect to x on this sine term, so we have minus pi square by L square. It is a constant, it is taken out, and the function is sin pi x by L. So this minus sign and this minus sign will cancel out in the next line. So these two minus signs cancels out, and as a result we have 2 h star square pi square by L cube. You can see that this L and L square, if you multiply, that results L cube. Integral from 0 to L sin pi x by L into sin pi x by L, that becomes sin square pi x by L dx. Now I am writing this 2 within this integral sign. So we have in the next slide average of p square equals to pi square h star square by L cube, integral from the limit 0 to L to sin square pi x by L dx. That results average of p square equals to pi square h star square by L cube, integral 0 to L, integral 0 to L 1 minus cos 2 pi x by L dx. Now where this term came from? We all know the formula that cos 2x equals to 1 minus 2 sin square x, right? So we can write 2 sin square x, that is equals to 1 minus cos 2x. I am just utilizing this formula. just utilizing this formula. So in the place of 2 sin square pi x by L, I can write 1 minus cos 2 pi x by L dx. So after integration we have, in the next slide we have average of p square equals to pi square h car square by L cube. Within the third bracket, I am just separating these two terms. So the first integral is integral 0 to L dx, and the second integral is integral 0 to L cos 2 pi x by L dx. After integration we have the first term becomes x with lower and upper limit as 0 to L, and if we integrate cos term, that gives us sine. So it becomes sine 2 pi x by L divided by 2 pi by L with limits 0 to L. Now, if we put this lower and upper limit in the position of x, then we get average of p square. Average of p square, that is equals to pi square h car square by L cube within third bracket. Final limit minus initial limit. So therefore, I am writing the final limit first, that is in the position of x, I am writing final limit, that is L. In the position of x, I am writing the final limit L minus lower limit. Here the lower limit is 0, so I am writing the lower limit. You all know the definite integral. In that case, the theory is final limit minus initial limit minus this 1 by 2 pi by L, that becomes L by 2 pi, and in the sine term, if we put the final and initial limit, then we have sine 2 pi L by x, that is in the position of x, I am writing L, minus sine 2 pi 0 by L, that is in the position of x, I am writing the lower limit 0. So that is why sine 2 pi 0 by L. So this L and this L cancels out, we all know that. So in the next slide we have average of p square, it is equals to pi square h car square by L cube within third bracket, L minus L by 2 pi within second bracket, sine 2 pi minus sine 0. And we all know that sine n pi is always 0. So therefore, sine n pi is always 0, where n is an integer, and sine 0 is obviously 0. So this sine 2 pi becomes 0, and same goes for sine 0. We all know that sine 0 is also 0. So the second term vanishes, and the only term that survives is the first term, that is L. So in the next slide we have average of p square, that is equals to pi square h car square by L cube. Within third bracket it is L minus L by 2 pi. So in the second term these two quantities become 0. So it is effectively 0 in the next line. So after calculation and simplification we have average of p square, that is equals to pi square h car square by L cube into L. Now this L and this L cube cancels out, that gives us L square in the denominator. So therefore the expectation value of p square for the given wave function psi of x is pi square h car square by L square. It is our required answer.